Meta is making one of the boldest infrastructure bets in the entire AI race. And at first glance, it looks like just another big tech headline. A new data center, a bigger budget, another expansion into artificial intelligence. But when you slow down and really look at what is happening, this move starts to feel much bigger, much heavier, and honestly much more complicated than it sounds. Because this is not just a building. This is a long-term commitment to a future where AI is not just important, but absolutely central to everything Meta does. And the real question is not just why they are spending this much, but what they are actually betting on. To understand this, you have to start with how the tech industry has changed over the last few years. Not long ago, companies like Meta were mostly focused on software, social platforms, apps, digital advertising systems, all things that could scale relatively quickly without needing massive physical expansion. But AI changed that equation completely. AI does not just live in code, it lives in machines, it lives in data centers, it lives in systems that need land, electricity, cooling, and constant maintenance. And once you step into that world, the rules are very different. Now, instead of just hiring engineers and shipping new features, companies have to build physical capacity. They need places where AI models can be trained, where massive data sets can be processed, and where millions of users can be served in real time. And the scale of that requirement is enormous. Training a single advanced model can require thousands of specialized chips running for extended periods, consuming huge amounts of power and generating significant heat. So what looks like a software race on the surface is actually an infrastructure race underneath. That is where Meta's decision starts to make more sense. If AI is going to be a core part of the future, then waiting for capacity to become available is not a good strategy. By the time you need it, it may already be too late. So instead, companies are trying to build ahead of demand. They are trying to create enough infrastructure not just for today, but for what they expect the world to look like in the next several years. And that means spending big, early, and aggressively. But that also explains why the number feels so large. $10 billion is not just about servers. It's about land acquisition, construction, specialized hardware, energy systems, cooling infrastructure, and long-term operational planning. These facilities are designed to run continuously, often for years, and they require a level of reliability that goes beyond a typical tech deployment. Once built, they become permanent pieces of the company's ecosystem. And this is where the story starts to shift from simple expansion to something more complex. Because building infrastructure at this scale doesn't just affect the company, it affects the location where it is built. A data center of this size draws enormous amounts of electricity. It needs stable and reliable power at all times. That means working closely with local energy providers, potentially upgrading grid capacity and ensuring that the system can handle the load without creating instability. At the same time, cooling becomes a major factor. AI data centers generate a lot of heat, and managing that heat often involves large-scale cooling systems. In many cases, that involves significant water usage, especially in warmer climates. And that introduces another layer of complexity, because now the project is not just about technology and business strategy, it's also about resource management. So when Meta builds a facility like this, it's not just plugging into an existing system, it's becoming part of that system. It's influencing how energy is distributed, how infrastructure is expanded, and how resources are allocated. And that creates a balance that has to be managed carefully. On one side, there are clear benefits. Large projects like this can create jobs, attract investment, and stimulate local economies. On the other side, there are real concerns about long-term sustainability and resource strain. And this is where the idea of the AI infrastructure arms race becomes very real. Meta is not the only company making moves like this. Other major players are also investing heavily in data centers, chips, and supporting systems. Everyone understands that AI capacity is becoming a key competitive advantage. The more capacity you have, the more models you can train, the more services you can run, and the more users you can support. So the incentive to build is strong. But when multiple companies are all building at the same time, the pressure on shared systems increases. Energy demand rises, construction demand rises, hardware demand rises, and suddenly what looked like independent projects start to interact with each other in unexpected ways. If too much demand hits the system at once, bottlenecks can form, costs can rise, timelines can stretch. There's also a strategic angle that often gets overlooked. By investing in its own infrastructure, Meta is reducing its reliance on external providers. Instead of depending entirely on third-party cloud services, it's creating its own environment, optimized for its own needs. That gives it more control over performance and potentially over cost in the long run. But it also means taking on more responsibility. If something goes wrong, there is no external system to fall back on.
And then there's the question of flexibility. Technology evolves quickly. New hardware gets developed. More efficient systems emerge. AI models change in how they're built and deployed. But physical infrastructure does not adapt as easily. A data center designed today reflects today's assumptions. If those assumptions change, adjusting can be difficult and expensive. So every large investment carries an element of long-term risk. This is why the scale of the spending matters so much. At smaller levels, mistakes can be corrected, systems can be upgraded or replaced without massive disruption. But at $10 billion, the stakes are higher. The decisions being made today will shape what Meta can do for years to come. That is what makes this feel less like a routine expansion and more like a defining move. At the same time, there's a broader shift happening in how we think about technology companies. For a long time, they were seen as mostly digital entities. Their impact was measured in users, engagement, and software capabilities. But as AI becomes more central, that image is changing. These companies are becoming builders of physical systems. They are becoming part of the infrastructure layer of the economy, not just the application layer. And that changes how they operate. It changes how they are regulated. It changes how they are evaluated by investors and by the public. Because once you're operating at this scale, your decisions have wider implications. They affect not just your platform, but the systems that support entire regions. So when you look at Meta's $10 billion data center investment, it's important to see both sides of the story. On one hand, it's a clear signal of confidence in AI. It shows that the company believes demand will continue to grow and that having the right infrastructure in place will be critical to staying competitive. On the other hand, it highlights the complexity of building that future. It shows that scaling AI is not just about writing better code, it's about managing resources, infrastructure, and long-term commitments. In the end, this is what makes the investment feel wilder than it looks. It's not just the size of the number, it's what that number represents. It represents a shift in the nature of the tech industry itself, from light, flexible, software-driven systems to heavy, resource-dependent, infrastructure-driven ones. And once that shift happens, the rules of the game start to change. The companies that succeed will not just be the ones with the best ideas, they'll be the ones that can build, sustain, and manage the systems those ideas depend on. And that's a very different kind of challenge. It's slower, more complex, and much harder to adjust once decisions are made. So this is not just a story about one company spending a lot of money. It's a glimpse into how the future of technology is being constructed piece by piece in ways that are much more physical, much more demanding, and much more consequential than most people realize. And as these investments continue to grow, the gap between what AI looks like on the surface and what it requires underneath is only going to become more important.